Okay guys, today in your review packet you're going to be expected to do some division problems involving these complex numbers, and that's just not something we've talked about yet, so I want to introduce you guys to that concept. When we are dividing, and just as a quick review, there are a few things that are no good when we're talking about a fraction. If I have the fraction 1 over 0, that's no good, right? We can't have zeros in denominators. If I'm talking about 1 over the square root of 3, that's no good. We haven't really talked about ways to eradicate that yet, but that's coming up. We can't have radicals in denominators, so we're going to have to be able to do something about that. And another thing we can't have in our denominator is an imaginary number. That's also no good. We've also talked about negatives, right? We'd rather not have negatives. We'd rather not, but it's not mathematically incorrect. So what we need to learn today is a way where if we are given an imaginary or a complex number in the denominator, how can we take that fraction and create a fraction that is equivalent to it that doesn't have a complex number in the denominator? So the only way for us to be able to do this is to start off with this concept of the complex conjugate. So what the conjugate says is it says that every mixed number, like 1 plus 2i, every mixed number has a conjugate that if you multiply that mixed number by it, you won't have an imaginary solution. So, for example, if I take 1 plus 2i and I multiply it by 2 plus I, and I go through this process, all right, so I've done my distribution and I'm left with 5i. That's a problem because I still have an imaginary number there. And it might seem like if you start with a complex number, you're going to get something that has an imaginary component, but that's not true. If I start with 1 plus 2i and I multiply it by its conjugate, that just means I'm going to take that plus sign and make it a minus sign. So its conjugate is 1 minus 2i. If I multiply 1 plus 2i by its conjugate, you will not get an imaginary solution. It will end up being real, and I'll show you why. 1 times 1 is 1. 1 times negative 2i is negative 2i. 2i times 1 is positive 2i, and that is where the magic is happening, because what's going to happen to these two terms is they're actually going to cancel each other out. So if you multiply by the conjugate, those middle terms will cancel, and then our final term is minus 4i squared, which we know is a good thing because I squared is actually just negative 1. So this just becomes 1 plus 4, or 5. And now we don't have an imaginary solution anymore. So we need to apply that logic to these fractions. So let's take a look at example number 1. Number 1 has 1 plus 3i, which is complex, over negative 2 plus I, which is also complex. And the problem with this is that we have a complex number in the denominator, and that is no good. So what we have to do is we have to multiply this fraction by something that is equivalent to 1, right? Because I can really only multiply things by 1 if I want to preserve the value of those things. But a version of 1 that will allow us to eliminate this complex number in the denominator. So there are a lot of different versions of 1. I could multiply by 1 over 1. That wouldn't really help us. I could multiply by 4 over 4. I think then I would still have a complex number in the denominator. There are a lot of other versions of 1 that I could use too. Right, all of these are 1s because they all are just dividing by themselves. But the one that I'm going to choose is this one. I hope that we can agree that this just equals 1. So I will preserve the value of this because all I'm doing is multiplying my fraction by 1. However, the good news about this 1 is that in the denominator, I have a conjugate of the denominator of my original fraction. So when I multiply, I won't have an imaginary number. Now I'll multiply my numerators, and I'll multiply my denominators just like I'm used to doing when I multiply. 1 times negative 2, 1 times negative I, 3i times negative 2, and 3i times negative I. And in my denominator, I will have 4 plus 2i minus 2i That's the good news. Minus I squared, more good news. So I'll simplify that beneath. In the numerator, I've got my negative 2. I now have a negative 7I, and I've got a plus 3, because remember that I squared became a negative 1. And in my denominator, I've got 4 plus 1, because that I squared is a negative 1. And that leaves me with 1 minus 7I over 5. And that is a fraction that is equivalent to this fraction, but does not have an imaginary number in its denominator. So we're going to be using that skill whenever you are dividing complex numbers. Let's see it happen one more time over here with example 2. Example 2 is a fraction that has an imaginary denominator, which we don't want. I need to find a version of 1 that's going to allow me to cancel that denominator, or at least make it so that it is no longer imaginary. So the version of 1 I'm going to choose is going to be the conjugate of this 2i, which would be negative 2i. But if I'm multiplying by 1, I need to make sure that it's a negative 2i over negative 2i. So I'll go ahead and I'll multiply. That's going to leave me with negative 8i minus 6i squared. Remember, the numerator can be whatever. We don't care about the numerator, but the denominator is important that it not be complex or imaginary. And then in my denominator, I will have negative 4i squared. So if I keep going with that, that's going to give me 6 minus 8i and 4. No longer do I have a complex denominator. All right? So keep working with this concept. This is going to be in all the practice problems that you do today that are between numbers 19 and 22. Keep working with this. This is due tomorrow, so make sure that you guys finish this up and submit it into the Google form.